Hi everyone, and welcome back to another episode of Dr. Carl Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going over using moles to work out balanced equations. Now this is relevant for both trilogy and triple pupils, however it is a higher tier only. So please give the video a thumbs up, subscribe to the channel, turn on all bell notifications, grab a pen, grab a calculator, grab some paper, and let's go ahead and jump in. Okay, so some key information then. So the balancing numbers in a symbol equation can be calculated from the masses of the reactants and the products. This is done by converting the masses in grams to amounts in moles and converting the number of moles into simple whole number ratios. So what does that mean? Let's look at some examples. So here I've got 54 grams of aluminium react with 160 grams of iron oxide to give 102 grams of aluminium oxide and 112 grams of iron. So what is the balanced equation? Now obviously you could just add the numbers in straight away, but we're going to prove this using the grams and moles. So first things first, you simply get your aluminium plus Fe2O3, write out your equation like we've done in previous videos, and then we're just going to write mass, mR, and moles down the side. Then 54 grams up the top here, 160 grams just here. We've got 102 grams of this one, and we've got 112 grams of iron. Okay, then your MRs. So if you're not sure how to work out MR, please do go through my other videos on how to calculate formula mass before you carry on. MR of aluminium is 27. Iron oxide is 160. This one is 102, and this one is 56. Okay, so working out the moles then, so 54 divided by 22 is going to come out at 2 moles. This one's going to come out as 1 mole. 102 over 102 is going to be 1 mole, and 112 over 56 is going to be 2 moles. Now, this one's relatively simple because you can see it straight away. However, what you do is if you divide each one by the smallest number of moles, just like this, you can see quite simply that's going to come out at 2, 1, 1, and 2, which just so happens to be the numbers you need to stick in front and balance the equation. Really well done if you follow that through. Okay, let's have another look at a different question. So balance the equation using moles when 8.5 grams of sodium nitrate is heated to produce 6.9 grams of sodium nitrite. Please note there's O3 here and O2 here, that's the difference. So balance this equation then. So NaNO3, we're just going to write out our chemical equation again, NaNO2 plus O2, and we're going to write mass, mR, and we're going to write moles down here. Okay, so we've got 8.5 grams here, and we've got 6.9. Now it doesn't tell us how much oxygen is produced, but obviously we know the conservation of mass tells us that the reaction on the left side, or the reactants, needs to be the same amount on this side for the products. So if we've got 8.5 grams, and we already know we've got 6.9, take away 6.9, that gives me 1.6 grams left over for my oxygen. Okay, my MRs then. So working out the MRs of sodium nitrate, that's going to give me 85. Sodium nitrite is going to be 69, and oxygen is going to be 32. So working out the moles then, so mass divided by MR equals my moles. So I'm going to work this one out, that's going to be 0.1 moles. This one is also going to be 0.1 moles, and then 1.6 divided by 32, it's going to be 0.05 moles. So you might be able to see it straight away, but if you can't, this is a slightly trickier one. Divide each one by the smallest number of moles. And so once we do that, hopefully we can see 0.1 divided by 0.05 is going to be 2, 2, and 1. Which just so happens to be your numbers that you need to put in front here to balance your equation using moles. Okay, slightly different question here. So which is the correctly balanced equation when 2.5 grams of hydrogen is reacted with 40 grams of O2, oxygen, to make 42.5 grams of product? So one of these equations is right, one of these equations is wrong, according to how much mass you've got. So let's have a look. Now, with this kind of question, it's all about laying it out so the examiner can see clearly what you've done. So what I'm going to do is I'm just going to write E1 for equation 1. I'm going to write 2H2 plus O2 goes to 2H2O. And I'm going to write mass, mR, and moles down the side. Then I've got E2 over here, and I'm going to write H2 plus O2 goes to H2O2. Then I'm going to write mass, mR, and moles. Okay, so now I'm going to start putting in some information I've got. So 2.5 grams of hydrogen, so that's 2.5 there. Oxygen is 40. And I've got 42.5 grams of product. Now remember, it says product here. It doesn't say water or hydrogen peroxide. It says product. So here I've got 2.5 grams, and I've got 40, and I've got 42.5. Okay, so MRs then. So hydrogen is 2, oxygen twice is going to be 32. That's going to be 18. That's going to be 2, 32, and that one's going to be 34. Let's work up my moles then. So 2.5 divided by 2 equals 1.25. 40 divided by 32 is going to be 1.25 again. And then 42.5 divided by 18 is going to be 2.36. This one then, 2.5 divided by 2 is 1.25. 40 divided by 32 is, let's do that again, 32 is 1.25. And then 42.5 divided by 34 is 1.25. Okay, so dividing each one by the smallest number of moles, 1.25, 1.25, 1.25, 1.25, 1.25, and 1.25. So hopefully you can see that's going to be 1, 1, and 1. This one here is going to be 1, 1, and doesn't quite fit. I think if I put it in really quickly, 2.36 divided by 1.25 is going to be 1.8. So you potentially could round that to 2. So here then we've got 1, but obviously there's a 2 there, so that doesn't fit. 1, that does fit. 1.82 doesn't quite fit. Whereas here, 1 reacts with 1 to react with 1 just there. So that fits nicely. Therefore, equation 2, you would say, is the correctly balanced equation. Okay, so today then we've calculated the number of moles or masses of a substance, and we've used that information to then correctly balance an equation using moles. Thank you very much for watching. Please do go through my other playlists for more GCSE science content. And remember, if you ever need help with the GCSE science, Dr. Kyle explains.